Good afternoon. Thank you for showing up for your learning, and welcome to Chapter 1 review. We're going to take up 1.5, Section 1.5 in the textbook. So that is on page 70, 1.5 review for Unit 1. So let's take a look. I've copied out the questions, and just to take a look at the questions here, we want to be really clear on what we're being asked for. So right now, we're being asked to solve each quadratic equation here in these first two cases. So let's take a look at those. So how are we going to solve that? So let's see. Our first example is 3x squared minus 2x minus 2. If we're not sure if a factoring solution is possible, just go ahead and crank quadratic formula. So make your little box. A is equal to 3, B is equal to negative 2, and C is equal to negative 2. All right. And then those answers we're going to put into the quadratic formula. The reason is because we have a quadratic equal to 0. When you have a quadratic that's equal to 0, the quadratic formula solves for x. That's its job. That's what it does. So let's do it. All right. So here, x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Sub in your values. X is equal to negative b, so that's 2, plus or minus the square root of negative 2, that's 4. The square of negative 2, sorry. And then subtract 4 times a times c. 4 times a is 12, times c is negative 24, but it's negative that, so that's plus 24. So now we know this would not have factored nicely because that's going to give us a plus or minus root of 28. 28 is not going to factor nicely, but it is 2 root 7. We're going to see that in a second. Okay, all over 2a, which would be all over 6. Okay, now let's simplify this. I'm going to just simplify my root over here. 4 plus 24 is root 28. Okay, that's what we're going to get there. All right, now let's see, what's 28? Well, 28 would be 2 times 14, 2 times 7. These is my pair of factors. Another way of writing 28 is equal to root 4 times 7. So that would be equal to, the square root of 4 is 2, so that's 2 root 7. So that's this. So let's put that in. X is equal to 2 plus or minus 2 root 7 over 6. Now let's simplify that even more. Okay, X is equal to 1 over 3, because that's 2 over 6, plus or minus 1/3 times root 7. Or we could put root 7 over 3 would be a nicer way to write that, to be quite honest. Mr. Jennings, x is equal to 1/3 plus or minus the square root of 7 over 3. There. That's my final answer. Those are the two exact roots. We were asked for exact answers. These are exact answers. If you gave a decimal, you would not be giving an exact answer. All right, root 7 is bigger than 1. So one of these is going to be positive, one of them is going to be negative. All right, now let's do the next one. So b, 6x squared minus 23x plus 20. There's nothing fancy that I can divide by to make these numbers smaller or more manageable, so I just crank quadratic formula. A is equal to 6, b is equal to negative 23, and c is equal to 20. So put it in there. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b is 23 plus or minus a, negative 4 times a, so that'd be negative 24. Negative 24 times c, so 20 times 24 gives me 480. 480. So I have minus, I have b squared, so that's 23 squared is, oh gosh, what is it? 23 squared. Well, 21 squared is 441, but that doesn't really help me do the mental math. Okay, so the answer is 529. Okay, so let's put that in there, 529. Now, something like that is a great mental math challenge. Just do 23 squared in your head. But I'm not very good at doing that right now because I'm a little distracted by this problem. So 529 minus, this was a times c was 120. And then I have that times negative 4, so that's minus 480. Okay, and I'm seeing that I could have factored this. That's going to give me the square root of 49, so that's plus or minus 7. Okay, all over 2 times a, that's all over 12. Okay, so this is equal to 23 plus or minus the square root of 49 over 12. This is equal to 23 plus or minus 7 all over 12. Let's see what those are. One of them is 16 over 12. So there, x is equal to 16 over 12, or that's with negative, right? 23 minus 7 is 16, 16 over 12, or x is equal to 23 plus 7 is 30 over 12. In all cases, these can be reduced, okay? We can take out a factor 4 here. X is equal to 4 over 3, that's this one, or x is equal to 4 divide that? No, 4 doesn't, but 2 does. Okay, so we can take a factor 2 out of both of these and a factor 3. So it's factor 6 that comes out of there. So divide that by 6, it's 5 over 2. Okay, and there's my exact answers. If you gave a decimal for that, it would not be exact unless you properly said you have to repeat that 0.3 repeating. Okay, now this next question, number 10, has just asked us to use something called the discriminant to determine the number of solutions to these quadratics. Okay, they're all equal to 0. I just ran out of space on that one. So here, the discriminant is part of the quadratic formula. It's there, b squared minus 4ac. And here we've been asked to use the discriminant to determine the number of roots for each equation. When you have your quadratic formula and b squared minus 4ac is positive like this, it means you're going to be plus or minusing something. It means you will have 2 roots because they're different. If you have the discriminant is equal to 0, then you'd have a plus or minus 0 there. That means that the 2 options are the same thing. Plus or minus 0 is saying I am 41 plus or minus 0 years old. It's a fancy way of saying I'm 41 years old. And then if the discriminant is negative, we can't take the square root of a negative number. That tells you that there are no solutions. There are no roots to that quadratic. In this case, there would be no solutions to something like this if we find that one of these discriminants is less than 0. So let's do them. You'll find that the discriminant is much faster than using the whole quadratic formula. So here, my discriminant is b squared minus 4ac. And so I just take these numbers. B squared is 4 squared, just sub in your numbers, minus 4 times 3 times c is minus 5. Okay, so there I know this is going to be positive because you have a negative times a negative makes a positive here. And this is also positive, so I have 2 positive things adding together. Okay, I can evaluate it. Okay, that's equal to 16. Negative 4 times 3 is 12. Negative 12 times negative 5 is positive 60. 16 plus 60, this is equal to 76. 76 is bigger than 0. Oh, you can't see that. 76 is bigger than 0. We know this. So since 76 is bigger than 0, therefore there are 2 solutions to 10a. Okay, let's do 10b in a different color because we're a little bit tight for space here. So we have b squared minus 4ac. All right, let's do it. This is equal to b squared is 25 minus 4 times negative 2 times negative 1. Okay, so it's 4 times negative 2 times negative 1. Did I write this question down right? Yeah, I did. I'm a little surprised that that this one is also positive. Okay, so 25 minus 4 times this is 8. This is negative 8 because I have 3 negatives here. So 3 negatives is still going to be negative. So this is 25 minus 8. That's still a positive number. That is 17. 17 is also greater than 0. So therefore, there are 2 solutions. Basically, if your negative 4ac is big and negative and bigger than b squared, then you will have no solutions. You will have no solutions to that equation. This one has 2. There's 2 values of x that make that true. Okay, and then in here, let's do again the discriminant, b squared minus 4ac. Just taking a look, I see a lot of factors of 4 and 4 there, and 12 and 9. So I'm pretty sure that this is going to cancel out. So 12 squared, my favorite number, minus, oh, it's negative 12 squared, but it's the same thing as 12 squared. Negative 12 squared, it's still 144 positive. Minus 4 times 9 times c, which is 4. Okay, so 9 times 4 times negative 4. Okay, so 4 times 4 is 16. 16 times 9 is, you guessed it, 144 minus 144. All right, so there you have it. It's 4 times 4 is 16. 16 times 9 is 144. Yeah. My mental math is so bad right now. 9 times 16 equals 144. Okay, it is. Yeah, it's very, very good, Mr. Jennings. 144 minus 144. Turns out that the number minus itself gives you 0. Since 0 is equal to 0, therefore there is one solution. Sorry, you can't see what I wrote there is one solution. Okay. So that's how you answer. That's how you use the discriminant and the quadratic formula to solve those types of problems. Quadratic formula is also useful for calculating what the roots are of a quadratic. So if you have something like here, I'll use Desmos and sketch you a quick quadratic here. So here's a quadratic, negative 3x squared plus 2x plus 5. And that has roots here and here. If we want to find those, you'll notice that this one happens at negative 1, 0. And this one happens at like 1 and 2/3. Okay, it factors a little bit ugly. Okay, it will factor cleanly. It will factor on integers, but it's hard to find the nice factoring of that. So what you could do is use quadratic formula, and it will output negative 1 and 1 and 2/3 as the answers to the quadratic formula for this quadratic. So that's how you can find the roots very easily with the quadratic formula. And then you could use that to create the factored form of this parabola, which would look like y is equal to negative 3 multiplied by x minus 1 multiplied by x, sorry, it's not x minus 1, it's x plus 1. Plus 1. And x minus, I said that's 1 and 2/3. So 1 and 2/3 is another way of saying 5/3. 5 over 3. 5 over 3. How did I get another bracket in there? I didn't put that. Notice that the two are the same. That's because they're the different forms of the same thing. Right? So that would be the factored form. And the quadratic formula can give me this value and this value. Of course, the signs will be flipped because it's telling you the value of the root. Root negative 1 and the root 1.1 and 2/3. Okay, yeah, so that's chapter 1.5. So if you have any questions, definitely send me an email or ask me in class. And thank you for showing up for your learning.